Hello everyone. In this video clip, I'm going to show you a question on probability distribution. This is a normal distribution. So how to solve this question is actually very easy, but you just need to follow the steps, the standard steps every time when you see this normal distribution questions. Now let's understand the question first. The score of 14,500 candidates in an examination are normally distributed. It's already informed us that it is a normal distribution. So for normal distribution, we need to have the mean. So the symbol for the mean is this, which is 58. And then we must have the standard deviation. If they give us the variance, always remember to change it to standard deviation. So in this case, standard deviation is 16. We need this too, so that we can change whatever score given us into the z-score. So the z-score basically is the score given minus the mean score and divided by the standard deviation. So we have to use this formula. Now, over here, we have the total sample. So over here, the total sample NS equals to 14,500. Now, basically, probability distribution is a way for us to find the probability of something. And that probability of something is not easily obtained like what we did for the normal probability. As in probability of A, you just take the number of A over the number of the total sample. But over here, we can't do that directly. So we have to go through the normal distribution way to find the probability of something. So over here, the first question, if the minimum score to get distinction is 70, so we need to estimate the number of candidates who score distinction in the examination. So we need to find out what is the probability of this sample to get distinction. So probability to get distinction is when they score, the number of students score, the marks must be more than 70. Okay. You can put greater than or greater equals, up to you. Nothing wrong, but normally distribution, we will just use the greater than. Okay, so the greater than and greater equals in normal distribution has no difference. Okay, no difference. So let's just change to the z-score first. Always from the normal score, we got to change to z-score because the z-score is a standard score. We have to use the standard normal distribution table for us to find the probability. So in order for us to use that table, we got to change everything so that it will be adjusted into the normal distribution value. So that is what we did, what we shall do. So we just take 70 minus the mean, which is 58, divided by 16. So over here, we will have z-score greater than, you use the calculator, you got 0.75. So once we reach here, always remember to sketch the bell curve. Okay, remember this bell curve basically is the z-score. Okay, the x-axis is now z-axis, yeah? And the one here is 0. So where is z equals to 0.75? It will be here. 0.75. And what do we want? We want greater than. That means we want this area. Okay, that means the area will represent the probability that is greater than 0.75. Now, according to the standard normal distribution table given, the value given is always the upper right tail. So when we refer to the score, to the normal distribution table, we look for 0.7 followed by 5. Then we will get 0.2266. That is the area on the right tail. And this one will represent the probability of the number of students who score distinction. Now, this is so for this way, this is a complicated way to find the probability of students who score more than 70. And this one, once we found the probability, we can actually use this one. The number of score greater than 70 over the number of the total sample. So isn't it this one is actually the normal probability way to find the probability? So now we need to find the number of candidates who score greater than 70. We just bring the total sample across to the other side. So the number of candidates who score, X is the score, the score greater than 70, that will be 0.2266 multiplied with the total S, which is 14,500. And with the calculator, we get 3,285.7. And of course, human, we do not have 0.7 human, okay? 0.7 candidates. So what do? We round it up. So let's round it up. We will have 3,286 candidates. So this will be the answer for A. Now for B, how do we find B? So for B, quite similar. They give us 5,800 candidates have scored more than H. So the probability when our score greater than H is given the number of candidates who score more than H. Okay, let's just put this one. This is the simple probability way. And since we have the number of candidates who score more than H, which is 5,800, so just put in. And the total NS, which is 14,500, just put in. So we will use the calculator. We have 0.4 here. Okay. Double check, 5800 divided by 14,500. We have 0.4. And at the same time, we also change this to our Z-score. Okay, so we will have probability of when Z-score greater than H minus 58 over 16 is equals to 0.4. And always use the bell curve to help us. Okay, the bell curve is very important. So on the bell curve, it is above the Z-axis, not the X-axis, because we already adjusted the whole graph back to the mean 0. And what do we want is, we want greater. So how do we sketch shape the graph? So when it is greater to a certain Z-score, it will get 0.4. Now we know that half of the graph is 0.5. So 0.4 must be here. Okay, and therefore our Z-score is on the positive side, right? So we need to find that Z-score using our standard normal distribution table, right? So from the table, now this is Z-score. I mean, we have the probability 0.4. So on the standard normal distribution table, we should get up here, these two is actually our Z-score, whereby inside is the probability. So now we have the probability, or I call it area of the curve. So now we have the area of the curve, which is 0.4. So we should look for 0.4 from the inside and then search the answer along the horizontal and the vertical margin. Okay, so from there, our Z-score, okay, is 0.253. Okay, so rearrange, we will get 62.048. And round it up, okay, let's round it off. So we will have H approximately to be 62. So that is how we find how we solve the question under the normal distribution. Now, for almost every year in the SPM, the probability distribution questions, the way they ask is like this. Okay, so that's it for the distribution question. I shall see you next class. See you in the next session.